Thanks for attending the Trilithic webinar series. My name is Tony Holmes. I'm the Applications Engineering Manager. Today we're going to talk about voice over IP test and measurements. You'll notice on your screen that there's a chat feature that's provided for you. Any questions that you have throughout this presentation, feel free to send those via the chat, and at the end I'll address each one of the questions. So let's get started. So as a webinar overview, here's what we're planning on discussing in this particular session. We're going to talk about voice over IP basics. We'll also talk about different challenges to the service quality. We'll discuss different voice over IP tests that can be conducted both before the voice over IP service is activated and then as part of the voice over IP service infrastructure. Then we'll also talk about installation testing. So with voice over IP, potential customer challenges is there's the confusion about unfamiliar technology. They're used to the cable companies providing a television service, but now we've branched off into providing phone service. So the thing is that that the concept is starting to customers are starting to understand it or embrace it a little bit more, but there's still that bit of a learning curve or a bit of where it's a bit unfamiliar to them. So this is where we have to, as technicians, has to be confident in what we're doing, just so that we're able to instill that confidence in the customer that this is a good service for them to have. Then there's also the concerns about emergency services. This is, not only are you carrying, the ability for a customer to contact, their family and friends, but you're also having the emergency 911 service. And customers could be a bit concerned with the fact that what if the cable goes out? Then how will they be able to contact emergency officials? So it's a concern. And then it's the fear that the quality won't be good, or at least as good as what they're used to. They're used to the twisted pair, and they're used to the quality that's there. They want a quality that is at least that good. Remembering experiences with immature technology, the thing is that as technology is new on the horizon, unless you're a techno buff, you may not want to dive off into the new technologies, because you know that it's still in the process of maturing to what it's going to ultimately be, and some customers don't want to be that testing ground and have experienced the effects of jitter, delay, and packet loss personally. Some of them have just from, if for nothing else, whether there's like cell phones and things like that, they've heard these types of delays and and voice breaking up, and they don't want that from their landline. So the thing is that by doing testing or some type of thorough testing, you can improve or increase the confidence level that the customer will have in the cable company. But the type of testing that you do must be quick to identify, isolate, and solve problems. It has to have the ability of knowing what the system's health is. Because the thing is, recruiting customers is very expensive. And long-term retention is critical to the return on investment. So the thing is that once you have the customer, you want to make sure that you're able to keep them. And just remember, the loss of a voice customer may also mean the loss of the rest of the triple play revenue. The thing is that when let's say you have a customer that has your phone service, and they're just not pleased with it. They were pleased with the digital set top, even your high-speed data. They were fine with that, but just something about the phone they didn't care for. So what they do is that they go back to their reliable, or what they consider to be their reliable service that they were used to before they signed up for the cable phone service. I can guarantee you that once they talk with the company that's providing that phone service, they're not going to be just satisfied with just bringing them over as a phone customer. What they're going to also want to do is they're going to want to try to sell them on the high-speed data. They'll also try to sell them on the television services as well. So the thing is that that don't think just because you're only losing the voice customer that's the only part of the service that's going to leave, because the thing is that once they start talking with another company, that they'll be offered other things as well. So it's very important that the services are tested and that you know that you're giving that customer the good quality service that they deserve. So as I mentioned earlier, that there's challenges to the quality of service that has to be addressed. Is that the service quality must be at least as good as PSTN, which is the public switch telephone network. It needs to be at least as good as that twisted pair. The speech quality must be comparable to industry standards. It's what the ear is used to hearing. It has to be at least comparable to that particular standard. The primary line reliability, consistent, continuous testing throughout the network. That primary line is that definitely has to be reliable. There's no alternative to consistent professional plant maintenance. Customers are looking for reliability, and they want to make sure that they can count on your phone service. Some of your other challenges is that it's on the same. The voice over IP is on the same physical network as your high-speed data, with impressionable return band. I mean, the return band that's where a lot of your noise will gather from ingress or what have you. There's common path distortions, impulse noise, signal to noise, laser clipping, just particular individual response issues. There's so many things that impacts the return that doesn't affect the forward as much, but it does affect the return. So you have those challenges. So it's important. In one of our other series of webinars, we've talked about return path testing and how to conduct proper maintenance on the return. Just doing those types of tests to ensure that it's a good return path will increase the likelihood that you're going to be providing a good phone service. The traditional testing that you already do, it has to be stepped up a notch. It has to go a little bit deeper because of this particular service. A variety of return path issues hamper the flawless communication, especially as in regards to the return path. Noise distortion and interference still cause problems. It's going to still cause you problems. Causes data slowdowns. That in many cases it would go unnoticed by a high-speed data subscriber, The retransmission of lost packets with high-speed data allows the customer to not notice that they've even had packets that were lost. So you get a little bit of an edge with a high-speed data because of the fact that it's able to retransmit the packets. Now, keep in mind that with high-speed data, though, is that as the packets are transmitted, that there would be a temporary slowdown of data transmission, so that part would be noticed. But the thing is that it'll be accepted because a lot of times it's not to the point that it's going to cause huge flags to come up. Poor installation craftsmanship is the #1 reason for callbacks. And not only the same infrastructure as data, but the same challenges that faces that is what you're going to run into with your voice over IP. Consequences of interference are more severe with voice over IP. So that's why I say doing it first, doing it right the first time is the most economical method. So it's making sure that it's a good quality install. I cannot say that enough. Having a good quality install will go a long way in ensuring that the voice over IP service will be a good service. So we're going to talk about now the voice over IP tests, some of the tests that can be made, and the tests that can be made before the service is even activated. So pre-infrastructure voice over IP testing. This prepares the system for voice over IP service offering by pre-testing. RTP, which is our real-time transport protocol, tests for packet loss, jitter, and delay with a MOS score. And we'll talk a little bit further about that a little bit later. And it's an inexpensive solution with low-cost head-in, with a low-cost head-in based server. So we're going to talk about that server with a Trilithic. It's a server called ACTS. ACTS, and that particular server will allow the meter in the field to communicate with the head-in and simulate a phone conversation. So your voice over IP installation testing. Testing is critical to ensure quality because as you know, it's definitely a very competitive market, and it's becoming more competitive as the days go by. The expectations must be met in order to succeed. Testing provides spot check of parameters that impact the call quality. It ensures that there's a headroom, that there's enough headroom so you're not right on the edge of having failures. It sets a baseline for trend analysis, what types of things, almost being able to anticipate what types of problems that you might have. And it enables your troubleshooting. This method allows testing voice over IP viability before installing voice over IP infrastructure. So before you even put the phone service in, you want to ensure that when the service is there, that it's going to perform the way that it's intended to perform. The test server that I was mentioning, the ACTS server, is installed in the NOC near the PSTN handoff point. And the communication takes place using RTP, the real-time transport protocol, and that's common to voice over IP signaling protocols. So the RTP test. The communication is established, so the meter in the field, it talks with the server, it makes that communications, and then the server and the analyzer synchronize test parameters and clocks. So it does a firm handshake from the field to the server, and it looks at it both ways. And then this particular communication occurs using RTP over UDP, which is User Datagram Protocol, at a pre-negotiated port. So the port is already set up that it's going to use, and then this is transmitted. Real-time transport protocol is the Internet standard protocol for the transport of real-time data, including audio and video. RTP is used in virtually all voice over IP architectures for video conferencing, media on demand, and just different other applications use it as well. It's a thin protocol. It supports content identification, timing, reconstruction, and detection of lost packets. Now, UDP transports data as a connectionless protocol using packet switching. Now, these results that come from this handshake are calculated and then compared to the limits that you set up in the meter itself, and then it'll give you a pass or fail based off of those limits that were set. So this is kind of a sample of what the results will look like. Now, if you notice the pass and fail results on the measurement display, and the MOS, which is the mean opinion score, at the bottom, it's MOS. Now, you can also note that the display on the right indicates a latency failure. So if you look at the upstream latency, it has an F next to it at 212 milliseconds, and it shows a fail. See, and it's probably because in that particular setup that they had latency. If it exceeds 200 milliseconds, then it says that show it as a fail. But the MOS is still within acceptable range. So even though that failed, your MOS was still, at a 4 or greater. And we'll talk about the specs that you'd want to see for these checks. It's still in an acceptable range. This indicates that the MOS is not sufficient in itself for determining acceptability of the service. When there's a problem, the tech can drill down for more specific results, and that's using the details. So after you hit the details tab, it shows you a lot more. So the tech can also see what's happening with regard to the test parameters for both downstream and upstream, because it's possible that the downstream could be performing fine, but the upstream is where you're having the problems. So in this, if you look at the downstream side on the left, it shows that there were 1,000 packets that were received, and of those, or that was transmitted, and of those 1,000 packets, that none of them were discarded, none of them were lost, and none of them were received out of order. And then it also gives you the lost periods that was happening, what times or amounts that you were having these lost packets, and then your latency, and then your jitter, the maximum amount of latency, and the max, min, and average jitter as well. and then it gives you your MOS score and your R factor, or your R value. And you will talk about that here in a little bit. But it gives you those particular parameters that you can now use as a good troubleshooting tool. So your mean opinion score. What your mean opinion score is, it's a subjective voice quality score based on the perception of a random group of people listening to speech over communication system. So this particular system was put together by multiple people's group of males and females rating voice qualities, and then putting it on a particular scale, with 1 being the worst and 5 being the best. And each one of the ones who were rating this, they rated that particular speech quality. So there were different types of impairments that were in there, different levels of problems, and we were able to, or the MOS score was then able to be generated based off of how the ear perceives that particular impairment. So the way that you can look at your mean opinion score, the way that you can rate it, 5 being excellent, that would be considered a perfect speech signal recorded in a quiet booth. A 5 is not achievable in our networks because of the codecs and the processing that the voice has to go through. So you can't receive a 5. A 4 is considered good. It's a natural, long distance telephone quality. Now with a 3 is considered fair. That's a communications quality, but requires some hearing effort. So you may hear maybe a little bit of interference in the background, or a little bit of breakup, but it's still pretty good. It's not something that you're going to just hang up the phone, or to where you lose connection. When you get to a 2, that's low quality and hard to understand the speech. So your voice is kind of breaking up, like it has breakup of speech. And then when it gets to a 1, it's bad. It's unclear speech, and it's a total breakdown, lack of service at all. So now your packet loss versus your MOS score. So how much packet loss can be tolerated before MOS begins to slip? And the thing is, it's not very much. Because of the real-time nature of voice over IP traffic, very little damage to the data stream can be repaired. 1% packet loss will noticeably degrade phone service. 4% packet loss renders phone service unusable. So if you look at the graph on the right side, your vertical axis is your MOS score. And then going across the bottom axis, or the horizontal axis, is the percentage of packet loss. So if you look at a MOS score of a 4, you can see that your packet loss is at 4%, and that's where it starts to drop off. And that's what we were what was explained about the 4% packet loss renders the phone service unusable. When you get to like a 3.5, you can see it's getting close to the point of where the service is unusable. So you can kind of use this as a basic graph of how the phone quality, when you start talking about packet loss, how it relates to the MOS score. Now, the R factor, we talked about that a little bit earlier when I talked about using the Details tab on your Voice over IP test. The R factor is a measure of voice quality ranging from a best case of 100 to the worst case of 0. The R factor uniquely determines the familiar mean opinion score, that MOS score. which is an arithmetic average of opinion when excellent quality is given to a score of 5, and so on. We covered that earlier. The R factor is defined in terms of several parameters associated with voice channel across a mixed switch circuit network, which is SCN, and a packet switch network. The parameters included in the computation of the R factor are, it's pretty extensive, covering such factors as echo, background noise, signal loss, then any type of codec impairments, and other factors. You can kind of look at the R factor as the technical version of the MOS score, whereas the MOS score is a subjective view of what the end user, the way that they would rate the quality based off of what they hear, but it's totally subjective. R factor uses technical data to come up with the number. So some of the parameters that that showed up when we were looking at the different tests that the voice over IP or the that you would run with the ACT server, one of them was latency. Latency is delay. Latency will show you how much time it takes for your voice to get to the end user. Now, latency causes echo and talker overlap. When delay is greater than 50 milliseconds, echo becomes a problem, and echo cancellation is required. Talker overlap is significant when one-way delay is greater than 250 milliseconds. So what happens is that when it gets above 250 milliseconds, let's say if I was on a phone conversation with somebody and they were on the other end, and I said, "Hey, how are you doing?" And I'm waiting on a response back from them, and I think that they don't hear me. So what I'll do is I'll say, "Did you hear me?" And then all of a sudden they start saying, "Hey, I'm doing fine." That's what latency is. It's the amount of delay. That's what's considered talker overlap. You can also maybe remember back a while ago that there used to be for international. If you made an international call, that when you had conversations, you know, the same thing, "Hey, how are you doing?" And then you're thinking that they're not on the other end, and then all of a sudden they respond back to you. That's an increased amount of latency or delay. Latency can seriously impair communications. It's usually a byproduct of switching and routing is what usually causes delay. And it must be less than 300 milliseconds round trip. One way, you don't want it to exceed 200 milliseconds. Another factor that you saw when we were looking at the voice over IP test is jitter. Now, what jitter is, it's when packets arrive at a destination out of the timing sequence. Now, remember I was talking about high-speed data. It has the ability of resending packets when a packet is not received properly. But now, because your voice over IP is real time, it doesn't have the ability of resending packets, because I mean, just think about it. If you're having a conversation, you're saying, you know, "Hey, how are you doing?" And if part of that was missing and it had to be resent, it's going to sound kind of funny by saying, "Hey, how doing?" It's out of order, so you don't want to do that. But there is a jitter buffer that allows timing sequences to be corrected. The jitter buffer is used to enable reordering of packets. Increasing size of jitter buffer threatens the delay. It should be less than twice packetization rate. Jitter buffer overflow causes packet loss. So even though the jitter corrects for timing sequences, but it increases the delay. And you can almost imagine that that if a packet went directly from point A to point B, it's going to be a lot faster than if it went from point A, then had to take a detour through the jitter buffer and put packets back in order and then go to the destination. So it's going to increase the amount of time that it takes to get there. So it increases the latency. And the jitter buffer only has the ability of correcting so many timing sequences. Once it fills that up, then what happens is that the jitter buffer overflows. When the jitter buffer overflows, those packets that could not be corrected or put back in the timing sequence, those particular packets would be lost. Those would be your lost packets. So packet loss. I mean, we talked about it in jitter from jitter overflow, but packet loss can be caused by network congestion, the jitter buffer overflow, or even ingress can cause you a packet loss. Random packet loss is less noticeable than bursty packet loss. So if it's a packet loss here and there, it's not as noticeable. But when it's a bursty, an amount of packet loss that's dropping out, then you're going to start having the speech of like, how are you doing? You have the breakup of speech, and that's what packet loss will cause. You can, when you look at it from a digital end, if you were looking at a channel, a digital channel that was tiling or macro blocking or freeze framing, that would be packet loss. That would be breakup of speech if it was a phone. If that particular QAM was for a phone. Your target is less than 1%, which is less noticeable when loss is random. Remember, as if loss is spread out, it's not going to be as noticeable. Once it gets to about 4%, it renders the service unusable. And remember, we looked at that graph. That graph kind of depicted, how the MOS score, how it dropped off, and when packet loss got to 4%, it drops out to where the service is unusable. So your recommended voice over IP results for your mean opinion score, you want it greater than 4. Greater than 4. The actual industry standard is a 3.6, but 4, I'd like to keep that as an easy number to remember, is to have it in the 4s. Your latency or one-way delay, you want it less than 200 milliseconds. Now remember, round trip, you want it less than 300 milliseconds. That's both for upstream and downstream. Jitter buffer, you want that less than 50 milliseconds. For packet loss, you want less than 1%. And just remember, these are some of the industry standards, but by all means, whatever your system specs are, those are the specs that you want to use. A lot of times the systems will have tighter specs just so that it's not running on the bare minimum. But this is typically what the industry is going to use for voice over IP specs. So hopefully something in this webinar kind of pointed you the direction of how to troubleshoot voice over IP problems. you'll notice that that this is troubleshooting it will not be much different than how you would troubleshoot a high-speed data problem or a digital problem for the downstream. You're still looking at the QAM carriers. You're still measuring your upstream as far as how everything is looking is from a return noise standpoint and things of that nature. So that particular testing is going to be very similar, but you want to make sure that you're using something that can look at those key metrics like the MOS score and looking at how much latency and what the jitter buffer is doing, what the how much what's the jitter buffer size and things of that nature. You want to be able to see that. So now I'll respond to the questions that were posted. Now, one of the things to keep in mind, I think the biggest thing that or the types of things that you'll see are the similar type of things, and I was just talking about it, that you're going to run into when you're looking at high-speed data problems. You'll notice that in this particular presentation, I went a lot into what is voice over IP, what are some of the metrics that are there, and I didn't go as deep into the actual troubleshooting from point A to point B. I did cover that in some of our other presentations. But some of the things that I do want to point out is that one is you want to use your tools just as if you were troubleshooting a high-speed data problem. That, for example, if I'm going in and a customer is complaining that their voice over IP, when they're talking on the phone, that the person on the other end says that their voice is breaking up, or when they're hearing that the voice is breaking up, coming to them, the same thing applies. So what you're going to do is that you're going to use your meter with your, if it's equipped with the voice over IP testing, and you're going to run the test. What I would expect to see or see to happen is that if I'm hearing the voice and it's breaking up, then my problem is going to be a downstream issue. It's going to be a downstream issue. So what I'm going to do is that I'm going to look at, if I know what my downstream frequency is for that particular voice over IP, for voice over IP, I'm going to use my QAM, and I'm going to look at the digital quality. And then I'm going to troubleshoot it as I would a digital problem. I'm going to look at my constellation. I'm going to see if it's a tight cluster of dots like I've talked about in the digital seminar or webinars. And then I'm also going to look at my MER, my BER, to see what the actual digital quality is. And then I'll make use of some of the equipment to look up under the QAM carrier, because one of your biggest problems that you're going to run into when you're troubleshooting voice over IP is going to be ingress. Ingress is probably one of the heaviest hitters that causes the problems. So after I check and I see that that I have an increased amount of latency, or from a jitter end of it, that the jitter buffer is high, it's higher than the 50 milliseconds. What I'm going to do is I'm going to start troubleshooting. I'm going to look at the return. I'm going to see how much noise is coming back from inside of the house, because a lot of times that noise is generated from the house itself. So I'm going to troubleshoot it from a noise perspective using my my spectrum analyzer in the meter, and then I'll troubleshoot it all the way back in a similar fashion. If it's something to where I'm hearing like what we'll call a robotic voice, usually a robotic voice is a strong indicator that there's some ingress. There's ingress in there, so I'm going to troubleshoot it as ingress. So other than that, it's the like I said, definitely don't, from a voice over IP standpoint, I wouldn't look at it as a a different style of troubleshooting. You want to use your techniques that you currently use to troubleshoot your digital problems and that you use to troubleshoot your high-speed data problems, and then have the added bit of being able to get the metrics from a voice over IP standpoint, and then you'll be able to identify the problems that you're having. If you do have any additional questions or concerns, feel free. We have a support forum that you're more than welcome to log into the forum and post questions, and that goes directly to our applications engineering group, and we respond to all of the forum questions. You can also send emails to support@trilithic.com. And there's also our website that has lots of information. Or feel free to give us a call directly at 1-800-344-2412, and then we can address and ask for the application support department, and we can address any type of problems that you might have at that particular time. All right. Well, I appreciate everybody coming out, and if you have any questions that's direct for me, feel free to send me an email. My email address will you should already have that, or you'll get an email that'll have that email address on it. Feel free to send me any information that you have or any questions that you have, and then I can address those on a one-on-one basis. All right. Once again, thanks a lot.